Okay. All right, everyone. Um, so today we're going to be doing lesson 112, which is going to be a 2x2 system of equations. And we're going to be talking about this in two parts, part 1 and part 2. Today we're going to be doing part 1. A system of equations is a collection of two or more equations with the same set of variables. In solving the system, we try to find values for each of the variables that will satisfy every equation in the system. So today we're going to be talking about only about 2x2 equations. So there's several different methods we use to solve. Today we're going to be focusing mostly on graphing. But graphing, you're going to look for where they intersect. Substitution, you're going to isolate one variable. And elimination, you're going to eliminate one variable. Okay? So let's talk about the characteristics of linear systems. So there's several different things that can happen. It can be consistent and independent, which is where the lines intersect exactly once and then they never touch again. Okay, that's the first type that can happen with a linear system. So for example, they intersect at, say, -1, 2. A consistent independent system is basically where one line overlaps the other line completely, and we call that infinitely many solutions because they're basically the same equation. And then lastly, we can have an inconsistent solution, which is when two lines are parallel, therefore they never intersect. Okay, so these are the systems of linear equations that can happen. Whichever method you choose, always start by reducing equations to their simplest form when possible. Okay, so moving on. Is somebody knocking? Oh, I'm going to zoom in here so that we can take a look at this equation. So the first thing that we need to do in order to solve this system of equations is we need to get both of them in what we call slope-intercept form, aka y equals mx plus b. So I'm going to take the first equation and I'm going to rearrange it. Our goal is to get y by itself and to get x on the other side, so I'm going to subtract 4x on both sides. That's going to give me -6y is equal to -4x plus 12. I'm then going to divide both sides by -6, aka each term by -6, and that's going to leave me with y equals -4 divided by -6 reduces to positive 2/3 x, and then 12 divided by -6 is -2. So here's my first equation that I'm going to have to graph, but before I do, I'm going to solve the other one to get it into slope-intercept form as well. So I'm going to take this equation and I'm going to get it into slope-intercept form by rearranging it. I'm going to rewrite it here at the bottom. I'm going to subtract 2x on both sides. That's going to give me 2y is equal to -2x plus 6. And then I'm going to divide both sides, each term by 2. That's going to leave me with y equals -2 divided by 2 is -1x. 6 divided by 2 is +3. So now I have two equations written in slope-intercept form, so I'm ready to graph them. To graph the first equation, I'm going to plot the y-intercept, which is -2. So start at -2 and put a point at 0, -2. My slope then tells me that I need to go up 2 units and then to the right 3 units. Up 2 and to the right 3. And then be aware, if you have a positive slope, you can also go down 2. Thank you. Down 2 and to the left 3 to continue the line. And once you have a good amount of points, you can then go ahead and connect those lines together. Do you need another pencil, or are you good? Or does it keep breaking?
It keeps breaking, yeah.
You can come borrow one if you want.
Thank you. Thanks.
Okay. So now we're going to go ahead and graph the other line, the one in the blue. And of course I'm going to start at my y-intercept of 3. So I go up 1, 2, 3 on the y-axis and plot a point. This number then tells me what my slope is, which is -1, which is really like -1 over 1, meaning I'm going to go down 1 unit and to the right 1. And I'm going to repeat that process until I have enough points so I can connect my line. I'm going to create a line. That wasn't that great. It's pretty hard to do sometimes. There we go. And I'm going to put arrowheads on both ends to indicate that it's going on forever. And then I'm going to look for where these two lines intersect, which is at what value? 3, 0, right?
Oh, 0.
Does everyone see why the solution is 3, 0 to this? So that's how you solve a system of equations using graphing method, okay? So before we move on to the next one, does anyone have any questions about the first? Okay. Let's go ahead and try the other one. So in this one, you're going to notice that one of these equations is already in slope-intercept form, so we will only need to rearrange the first one. I'm going to rewrite it here so that we're able to rearrange it. And our goal, of course, is to get y by itself. To do that, I'm going to subtract 8x on both sides. That's going to leave me with -4y is equal to -8x plus 8. I'm then going to divide both sides by -4. -8 divided by -4 is +2. 8 divided by -4 is -2. So all I'm doing is rearranging equations. And remember, when you rearrange, you want the x term to be before the regular constant. And for the reason for that is, when we think of y-intercept or slope-intercept form, the mx is first, and we need it to be first to be in that form. So does anyone have any questions on how I obtained slope-intercept form there? No. Okay. So I'm going to graph this one in blue so you can keep track of it. I start by finding my y-intercept, which is 4. So I start at 4, 0, which is right here. The slope, I always put it over 1 if it's not already a fraction. That tells me how much to go up and how much to go over. So I go up 2 units and over 1 and plot my point. Now you're going to notice that I can't go up 2 and over 1 again because I run out of room on my table or graph. So I'm going to go down 2 and over 1, which continues the same line. Once I have a few points, I can go ahead and connect those points with a line, which looks like this. Put arrowheads on the end because it is infinite. And then I'm going to do the same procedure with my other equation. I start at my y-intercept, which is at -2, and I go up 2 over 1, and I repeat the same process. I'm going to connect my dots. And what you're going to notice is, do these two lines ever intersect?
No.
Will they ever intersect? No, because they have the same slope. Does everyone see how they have the same slope? Lines with the same slope never intersect, which means we have?
Solution.
Good. Very good.
Parallel lines never intersect.
Exactly. Very good. Parallel lines never intersect. They are notated by the slope. Yes?
So, if you ever have a question like this, and you're not given a graph or anything, if you see that there's like the same x value in relation to y.
You mean the same slope value?
Yeah.
Yeah. If they have the same m value, once they're in that format, you can automatically say they are parallel.
Alright.
Yep. Good
So
question.
if you wouldn't have to show our work on a question like that, we'd just be able to write my solution. Or
Correct. If you got it to that point, yes. Anyone else? Okay. So now we're going to talk about interpreting a 2x2 system. So I'm going to make this a little bit bigger. So this is kind of what we call like a guess and check model. And this gives us the ability to basically figure out if a solution has a system based on plugging in points. So the first thing you need to do is you're going to have to get each of these equations into slope-intercept form just like we did before. So I'm going to take my first equation and rewrite it in a goal to get it into slope-intercept form again. So I'm going to add 3x to both sides because our goal is to isolate the y. That's going to give me 2y is equal to 3x plus 8. And then I divide both sides, aka all terms, by 2, which gives me the equation y equals 3/2 x plus 4. Now I'm going to do the same thing with my second equation. That's going to be x plus 4y is equal to -12. I'm going to subtract x on both sides. That gives me 4y equals -x is the same thing as -1x minus 12. And lastly, I divide by the 4. Y is equal to -1/4 x minus 3. So that's just rearranging. And these are basically my two equations. And what you're going to write up here on the line is the equation. So this one, first one is y1. And the second one is y2. And what we're basically going to do is we're going to plug points into each of these equations until we get the same y value. So I'm going to make some lines on my table here. And what you're going to do here is, on the question it says on the domain of these integers. Domain means what?
X axis.
X values.
X value.
Good, so they're telling me to do it on the x values from -6 to -2. So that's -6, -5, -4, -3, and -2. I'm going to take these values and plug them into each of my equations. So basically I'm just replacing the x with those values, and I'm just going to do all this math strictly on the calculator, okay? So basically 2 divided by 3 times -6 plus 4, that gives me -5. And then I'm going to do the same math here. -1/4 times -6 minus 3. If I do that math, I'm going to get 6 divided by 4 minus 3. That gives me -1.5. So as you can see, these results are not the same, so we need to keep going until we get the same result, okay?
Can you zoom in a little on that thing? I can't really see.
Is that better?
Yeah. Thanks.
You're welcome. So now I'm going to do the same thing. I'm going to plug in the next value. So I'm going to do 3 divided by 2 times -5 plus 4, which gives me -3.5. And then I'm going to do the same thing over here. Bless you, 5.25. So we still don't have the same value, so we still need to keep going. So this is giving me -2. And if I do the math over here, this also gives me -2. So notice here we got the same result. So let's talk about what that means. That means that if we plug in the same x value into two equations and they yield the same y result, that's their solution to the system. Yeah?
Why did we start adding 4 to the
Yeah.
to the y2?
Oh, I just wrote it wrong. I'm sorry. I did the math right though. I'm sorry. So yeah, you're basically just plugging them into their equations. So what that means is when you get the same answer, when you plug in the same x value, that means that the solution to your system is that x value, comma, whatever that y value you get is, which is -4, -2. So does everybody understand the general idea here of what to do when you're checking a system like that? You're going to plug in until you get the same value. If you don't get the same value, they're not going to have a solution. And if you do get the same value, eventually you don't have to keep going because we already know the answer. Okay? So that's everything